So in the southeast U.S., in particular Florida, is a hotspot for turtles and a really exciting area to do research to learn more about sea turtle populations. Sea turtles in Florida are important because all the species are covered by the Endangered Species Act. Some of them are listed as threatened and some of them as endangered species. And in all of the endangered species reviews of sea turtle species, it always has come up that more in-water research was necessary. So most of what's known about sea turtle populations comes from nesting beaches, and that information is very important and gives us a critical insight to the number of adult females. But what it does not do is tell us anything about adult males or any of the juvenile or subadult age classes of sea turtles. That's what brings us here to Central Florida, and we're on the West Gulf Coast working in Chassahowitzka National Wildlife Refuge. And the reason we're here is that we'd heard reports that there were large numbers of turtles here, and we wanted to target an area where we could establish a long-term monitoring site to understand how sea turtles are utilizing the habitat in particular, as well as whether the populations are increasing, decreasing. So we initiated research here in 2014 and came out to just do some pilot surveys, just come out and get out on the water and look around to see what we saw. And we've now expanded that this year to do more formalized transects. So we'll run a line in the vessel with a couple observers up on the bow that are looking to the front and then each side of the vessel scanning the water. And when we see a turtle, we'll call out what species it is, what age class it is, and whether it's right in front of the vessel or how many meters off the vessel it is, and an angle. And we can use that information then to calculate the relative abundance of turtles in the area. So some animals then we will target to capture for satellite tracking. Greens are really difficult to capture. They're very fast. They make a lot of quick turns and it takes a few minutes following them to finally catch them. And we're also targeting Kemp's Ridley sea turtles. Kemp's Ridleys are a little more docile in the water. They don't have the speed or endurance, and so we'll follow them for a short bit and they'll usually settle down on the bottom before we can get into the water and capture them. Once on board the vessel, we put them in the shade so they don't get too hot, and we measure their carapace length and width. We will then put flipper tags on the animals to identify them, and then finally we will put the satellite tag on, and we set the satellite tag onto the epoxy and hold that individual for an hour and a half or 2 hours to have the epoxy set, and then we release it back into the water at the capture location. The data the satellite tags collect are GPS location. They also collect dive information, and they collect water temperature information. And it's yielding some really important information about how animals are utilizing this habitat. They definitely stay in here through the fall and then leave as the water temperatures drop. But we did have one tag that we put on a green sea turtle last year, and that turtle did in fact return again this year to the same area. So it appears that the animals that are here are residents and return year after year to this habitat. On this trip we also captured loggerhead sea turtles and green sea turtles. Those are a little bit different, but we do take tissue samples of those animals, and that's important because we can use the tissue samples for genetics to understand what nesting beach assemblage those sea turtles originated from and what sea turtle populations are feeding in the waters off the west coast of Florida. So all the information that we're collecting, from the abundance to the genetics to the habitat use, it allows NOAA Fisheries to validate the management decisions that are being made and allows the agency to make sound conservation and management decisions for sea turtle populations.